All right, so for this exercise, we're looking at the employee attrition data. We're trying to create a logistical regression that can help us determine and predict whether an employee will leave our organization or not. So after playing around with some of the variables, this was the group of them that we got the highest value here for, this KS UDIN. So basically, this means that this model with all of these factors included will predict whether an employee leaves the organization or not, and predict that correctly 35% of the time. So some of the variables we included were total working hours, job involvement, job satisfaction, environment satisfaction, years with current manager, and years since last promotion. So we can look a little bit more at how these impact this outcome, looking down here in our parameter estimates.
So our parameter estimates highlight the model equation we were asked about, and the intercept is 2.15 with attrition equaling 0.49 times job involvement plus 0.3 times job satisfaction plus 0.3 times environment satisfaction minus 0.11 for years since last promotion, and plus 0.07 times total working years.
So then we'll go into some of the assumptions about a logistical regression and kind of how we can understand the predictive validity of this. But just overall, again, that model only performs accurately at about 35% of the time. So that's not a very high level of performance. And with these assumptions, we'll kind of discuss maybe why this is occurring.
Yeah, so we're going to look at some of the different assumptions of the logistic regression. So first of these assumptions is whether or not the logistic regression is binary. And as you can see, whether the question is whether or not there was employee attrition. So yes or no. Those are the two variables. So yes or no, binary, perfect. The observations are independent of one another. If you go down to the right, you can see some of the, if you do a correlation matrix, you can see all the different variables have a low correlation with one another. There's no multi-collinearity from that. There are extreme outliers. This may be due to retirements as these extreme outliers. I mean, one of them, if you highlight there, it says that they have 40 years of work experience, or 34 years of work experience. So the assumption could be that they might have retired, maybe not left the company. There's a linear relationship between the independent variables and the logit of the dependent variable. And then as far as the observations, you can see up in the top middle says observations used 1,470, which is plenty as far as pulling away some substantial results.
All right, so now for the second part of this exercise, I'm going to recreate that same logistic regression model, but I'm going to use the GLM, which if you go to objects is just right next to logistic regression generalized linear model. And so I've already entered all of the variables into this equation, but the one big difference from the logistic regression is that because we're doing a linear model, our outcome variable, so attrition needs to be continuous. You can't have a categorical variable there. So I needed to use a calculated field to create this measure of attrition, which you can see is just using an if-else statement to make zeros and ones, ones being someone did leave, zeros being they did not. And that is the variable that I used over here in the response section. So as you can see, this model is the same as the logistic regression. It's just now in a different format.
Okay, and to wrap up this exercise 7 video, we're going to jump into the second part of that 7.2 question, focusing on generalized linear models. I've created a secondary one here that is supposed to match the one that found in the textbook. It's on page 150 under chapter 6. As you can see here, this is how it's laid out. Go and switch back. Same results. I'll walk through it a little bit more in depth after I show you the variables that we used. And we can double check over here. You can see I have used the same continuous effects and classification effect to come to these assumptions. And this is within the house price data set. So overall, this is a pretty straightforward ending. The entire goal here was to essentially practice and match what was already previously created, which we have done. If you wanted to analyze this model further, which isn't necessarily the case here, you can expand it, look at the different dimensions, history, fit statistics is the one that we usually find to be most intriguing. However, as you can see, once again, I will show you the data on this page compared to the one in the textbook, and they are the exact same. So, thank you all for watching and listening to our video today. We hope you learned something. I know we all did.